So today I'm talking about from Postgres to Minimalist Lakehouse, and the point of the story is that short a little bit about me already. Yes, thank you. He already mentioned I come from Brussels. I usually actually live for the past 6 years in Berlin, Germany. I just moved back to Brussels. I have a decade of experience in various companies that you may have heard. And I'll do data engineering, and I'm a developer advocate at MotherDuck, which is DuckDB in the cloud. Who has heard about DuckDB? Raise your hands. Who is using DuckDB? Keep your hands up. Okay, who have heard about DuckLake? Okay, all right, few. Who is here just for the ducks? Come on, everybody is here, please. So there is two YouTube channel. I'm quite active, my personal one and the one of MotherDuck, if you want to hear about data engineering and DuckDB. So building a data stack is hard. I'm just looking at the time because we swipe it up. And the reason for that is this landscape. You know what is it? It's a mad landscape. It's updated every year, and you cannot even read. The company is so small. You can have it in full definition in Zoom over there. But the point is, it's while we talk about modern data stack and new tools, it is still really hard to stitch a lot of things together. It's just a lot of tools, and just like it used to be way more painful. Who knows what it is? Yeah, what is it? Yeah, okay. So if you're still working with that, you probably should quit your job before killing yourself. And this is the famous Hadoop. So it was much more painful. So what happened? Why is it still painful? And we all start from here, meaning we have OLTP database, a transactional database, MySQL, Postgres. Who has the operational database, MySQL or Postgres? Raise your hands. Yeah, I guess everybody. As soon as you have a web application, a service, you have a transactional database. And Postgres has been really popular. So we all start from here. And yet, getting there with the landscape we are is not so obvious. So the question here is that can we build a minimalist modern lakehouse that enables us to run analytics at scale for BI and ad hoc exploration, scheduled and execute pipeline, an easy embedded and serve analytics, and please, a better user experience. I'm sure that's one of you at some point, right? We used to wait long for a PR to be completed for whatever reason. And compared to a web developer vibe coding an app, you just, run a web local server and you see directly the beautiful app webs. And yet for us, it's so painful. So let's try to have a better experience and be simple. So what we need here is an object storage and a laptop. And I'm also going to use GitHub. GitHub Codespace is basically a dev container. It's just a remote laptop because I don't trust the Wi-Fi here. Maybe I should. And so who has an object storage? Raise your hand. So it could be an S3, it could be Azure, it could be Cloud. Yeah, everybody, okay? And I guess everybody has a laptop. Right? I don't know what you're doing here, except for the ducks. Yeah, forget about that. So what is DuckDB? Just quick reminder, it's an in-person analytical database. It has more than 5 million downloads per week on the Python client only. And you can just use pip install DuckDB. You don't need any server or whatsoever. And you can start crunch your data. You can start persist your database. We've just here and start querying and reading from CSV, Parquet, export it to whatever format that you want. It runs anywhere. You have multiple clients. It's built in C++, so really efficient and lightweight. A lot of people are using with Python. We're going to use the CLI actually. Even no programming language server, just the CLI and SQL. And you have also a beautiful UI. If you're scared about my terminal today, don't worry. There is also an UI. I'm just also going to put that, which is the CEO from 5chan, which say that based on real data that Redshift shared on the usability of the queries of their user in Snowflake 2, is the distribution of the data scan. Roughly speaking, I'll summarize for you. Around 75% of people the queries scanning the data are less than 1 gigabyte of data, and 90% are, in between up to 10 gigabytes of data. Okay, so basically, long story short, if you are under 1 gigabyte of data per table per query, you are much above the average case. Starting 10 gigabytes, you start to be, on the edge case, and the less, the harder, the higher the size to begin it is. And why I'm saying that is that big data as a task, when we're talking about user experience, right? This is the Hadoop era. And so we have a lot of overhead regarding the network because we do distribute compute, right? DuckDB embrace a new paradigm where you just have a single node. So we scale up, we put a bigger machine, right? And we don't have this network overhead. A lot of people ask sometimes on MotherDuck, DuckDB in the cloud, why are you so fast? Well, it's just by design, okay? So let's do first demo. So this is where I'm gonna struggle to speak at the same time. Let's try. Do you want to do my older? That would be great. Yeah, thank you. So we're gonna do just launch a DuckDB session. Gonna see because I don't see anything on that screen, and I'm gonna just put the timers that you see. So DuckDB can be installed in one line of code. It's just a curl command, and you know what? Yeah, of course, like this. All right. So I'm just gonna reinstall DuckDB. You see, it's done. So there's nothing like you can do it. Don't worry. So I'm gonna put the timer on so that we see. I'm gonna create S3 secrets. So I'm already authenticated to AWS through the AWS CLI. And so now those secrets there. And I'm gonna create a private Parquet file on S3. Boom, done. 3 line of code. Actually, 2 line. You're not paying attention. 3 line of code with the installation included, right? To query a Parquet file and start computing. I challenge you to do that in less than code and less infrastructure. I just have my laptop, right? The whole topic is Minimalist Lakehouse, right? So let's go further. So this is actually already a 1 gigabyte data because we have about 4 millions of data. So remember, around the 75%. So I'm going to take the edge case. Whatever you're going to see here should be slower than whatever you're going to experiment when you go back on your data. So I'm going to run also a simple query to get, it's on Hacker News, what's the most commented stories. And you see it's taking actually 1 second. And I can see the most commented stories was Apple announced change to iOS, Biden signed TikTok bill into law, GPT 4.0. Anyway, it is fast. I'm going to skip this one. So now what I'm going to do, because if you remember the story, we are starting from Postgres, okay? So the beauty with DuckDB is that I can actually connect directly from Postgres on MySQL within DuckDB and start querying from there. So I'm going to create a secret to connect to my Postgres database. And now basically what I'm going to do is an attach command. So an attach command is basically really typically a DuckDB command. It's where it's all, I'm just taking 1 sec. It's just basically a way to connect to a database. I can connect to a local database. I can connect to a Postgres database, a MySQL. I can even connect to a BigQuery or Snowflake, okay? And what DuckDB is going to do is push down some compute on the remote database, right? And, do all their stuff of analytical query locally. So here, what is happening? Okay. So here, what I'm going to do is, so this is now if I do a show databases, you see that I'm saying my Postgres database. And so if I do show tables, I see those 4 tables in Postgres. And just to prove you that I'm not lying, this Postgres is hosted on Supabase. And this is the 4 tables that you can see. So you see I have 1 table with 4 gigabytes. And I have 1 table of 255 gigabytes. I'm telling you that I was going to the largest extreme. But we're still going to be able to do it. Don't worry. We'll still be. So just for information, this is data about air quality sensors. So it's like tons of data that keep sensors data on air quality every minute, a bit around the world. Yes, it is generated. But I do have some sensor data that actually with a real sensor, but that's for the purpose of the exercise here. So what can you do here? So now we can start to query. For example, this one is going to take a long time because that's the 255 gigabytes of data, right? So that's, we're going to be there still. It still take a couple of minutes. But what I want to show you is, for example, taking this query. But we're going to run it directly on Postgres. So I have a Postgres client over there. And I'm going to run on a sample. So that's the 4 gigabytes of data, okay? I didn't put the timing. I'm going to count. You're going to see that it's 4, 5 seconds, hopefully. It's a bit longer. Okay, that's really long. Okay, I need to refresh the states. Let me try with the DuckDB client because... So... Sensor. So I'm going to do actually the query from DuckDB itself. So I'm already selecting the right database, which is the Postgres database. And here is going to push everything from there. So you see a couple of seconds. And the reason for that, I think the client just hang off, but it's okay. It's a live demo. So 12 seconds. Okay, so this is query from Postgres and returning the result. Okay, this is where you should start to look on analytical database, because in analytical world we are used to have seconds of latency for a query, and it's okay for a business intelligence tool. So for pipeline, up to a minute. In the OLTP world, that's really bad. Okay, so once you start to have query on Postgres that takes 10 seconds to up to a minute, that's really bad. And as you can see, the type of the query here that I'm taking is basically all analytical queries. So I'm doing average on basically 4 gigabytes of data. Okay, so now coming back to the slide, we did a bit of a demo where we take data we can read data from Postgres, right? And using DuckDB. But we haven't used DuckDB yet, right? So what's the point? We're going to see what's the point. What I could do is basically read from DuckDB, and right here, I can just simply do this. And what you're going to do is that, let's do this quickly, actually. That you see. So I'm creating a local DuckDB database, and I'm going to create a DuckDB table based on my 4 gigabytes of data that is on Postgres, right? So this is going to take, remember, it's like 4 million of rows. So it's going to take a few seconds. And when it's done, then I can start using DuckDB itself, query my data locally, or, export it to Parquet. Again, I just want to stress out, I have no programming language. I just have a CLI. And I just have SQL. This is the only thing I need for my stack for the moment, and we've been crashing a lot of queries, right? So it's there. So let's do again the same query that we had before using DuckDB. Boom, less than a second. Remember, was 12 seconds Postgres, less than a second with DuckDB. All right, moving on. We have more demo. I'm rushing. DuckLake. So DuckLake is a table format. A table format you may have heard about Iceberg and Delta Lake. That's the equivalent. It released this year by the team of DuckDB. It's really simple. Again, you use a DuckDB client. You can also use Spark and connect to DuckLake. And the main idea of table format is that it's open and you can do ACID transaction. You cannot update a Parquet file. That's not possible. And it's just easy for partition and high volume. In terms of architecture, the main difference is that all those Iceberg and Delta Lake, they also have a metadata layer, and all those metadata files are in the object storage. So you have your Parquet file, then you have JSON, which contain the delete operation, the update operations, so all the metadata are there. The problem with that is that any client that need to resolve those tables, they need to do multiple round trips around S3 to read those JSON file or Avro file, and that's pretty slow. DuckLake take a different architecture. All the metadata are sitting in a database, in a Postgres database, for example, and your data is still on S3 or any object storage. So that makes the thing much faster and also much simpler to adopt. All right, another demo. Sorry, Edward. So let's go over DuckLake. So now what I'm going to do is, again, create my secrets. I have my source data. I have actually already done. I'm going to do that because I'm not sure if I closed the session. And what I'm going to do now is create another secrets for another Postgres database that contain my metadata. And here I'm going to specify where I want my DuckLake to store. And you see it's a S3 bucket that I created. And so that's it. The secret is done. And now I'm going to use the same attach command I used before, but for DuckLake. And now if I do, show database, I see we have DuckLake. And if I show tables, I have my tables. The metadata is in Postgres database, and the data is in S3. I believe, for example, this table is there, which contain it's a small table on device. As you see, I have a bunch of Parquet file. This one is really small. So that's Parquet file, and I can query it directly, from my DuckDB client, which is be here in Python against anywhere. Okay. So this is about that. Let's do another run again. The same query again run, but now my data on the same table is on DuckLake. Okay. So you remember we had less than a second. Now we have 2 to 3 seconds because the data before was in local DuckDB. Here, my data is on S3. So there is a bit of network traffic, right? But it's still much more performant than the 12 seconds we got initially from Postgres. Okay. Just looking at the time. So I want to give a word on orchestration because Mehdi, you've been doing that, everything on the laptop. I just want to stress out that first I said I'm on a code space. So you can launch a code space here and you see it's 64 gigabyte of RAM. I actually have the same on my laptop, but it's just for network Wi-Fi. I said I don't trust the Wi-Fi. But it's really easy to launch like, a remote desktop in one click if you're using GitHub. The other thing I want to mention is that regarding orchestration, GitHub Action is perfect. You can have large runner on GitHub Action up to 256 gigabytes of RAM. You remember the 75%, one less gigabytes. So you're much comfortable, don't worry with that. And you could do a pipeline to ingest incrementally because we've done some, group by against the whole table. But when you do incremental load, that looks like this. You can delete the data from a specific range and then again insert the data based on that range. And you just run this SQL file to a DuckDB CLI. So we've been in interactive mode in SQL, but you can just pass the SQL file and run it and do it in GitHub Action. That's what I've been doing for the past year, as you can see, for this project. Which is DuckDB stats. Yeah, it's there. So it's a live project that gets me all the downloads of DuckDB over time. And so there is quite data because there's a lot of downloads. Working fine. No worries. Just GitHub. No specific complex orchestration there. All right. I have 5 minutes. 2 minutes. I can do it. Just a quick word about the MotherDuck is that, so everything you do, if you can hold, to connect to MotherDuck, basically, the only thing I need to do is this. I have a MotherDuck token in my environment variable, and boom, I'm connected to the cloud. So anywhere you can run DuckDB, you can connect to MotherDuck to the cloud. And so now if I do this, I have all my cloud database. And if I start run some query, some part we run on the cloud with heavier machine, some part we run locally. So I reuse efficiency locally. We support also DuckLake. So everything I show you in the open source, we support self-manage, okay? And so just for the sake, I show you that Here, I run on the largest table. You remember the 255 gigabyte of data, right? This is the one. Less than a minute, okay? It's not optimized at all. I just throw a group by on everything, okay? If we look at the sample of data, we have 1 second. Everything is self-managed. You have an UI that you can use also locally, and other features in MotherDuck. So, yeah, takeaway. I have 1 minute for this. Design your pipeline for the 90%, not the 10%. Because even if you have a lot of data, yeah, but what if I have 1 terabyte of backfill? Yeah, but you just do a workaround. You process, 3 months by 3 months. I've done that. I've done that multiple times because back then, in a couple of years ago, the cloud actually didn't provide machines sometimes and so you needed to do those workarounds. But if it's for once a month, it will still be much cheaper in your time than designing your platform for, the biggest pipeline. So most look at what you're scanning in terms of data and adapt to that. And I can tell you, on average, it's less than 1 gigabyte and 10 gigabytes on data, fresh data that you connect. DuckDB can connect to everything. We saw Postgres, and I can create a table directly to S3 with just a CLI. It can run everywhere. It's simple. GitHub Action are criminally underrated. And MotherDuck brings the big duck in the cloud. And if you are really, I think we did it in less than 20 minutes, hopefully. So we had our CLI running. We run some analytics on it on S3 and using DuckLake. Everything under 20 minutes with just a laptop, an S3 bucket, and an existing Postgres database. And if you have some question or you just find a DuckDB fan, I have some stickers for you so you can come afterwards. Thank you.